Welcome to What That Means with Camille, where we take the confusion out of tech jargon and encourage more meaningful conversation about cybersecurity. Here is your host, Camille Morhart.
Welcome to Cybersecurity Inside. This episode of What That Means, we're going to talk about natural language processing. We're going to talk about artificial intelligence. We're going to talk about AI in the context of cybersecurity and lots of other things with the director of AI in the office of the CTO at Google, Ashwin Ram. Welcome to the podcast.
Thank you, Camille. Happy to be here.
So I want to start our conversation more specific and then go broad. And I think often we go the opposite direction. But we're having a conversation right now. We're two human beings. And I understand that it's a little bit difficult for AI to actually have a conversation. And I'm wondering if you can explain why that's hard and if it's true that it's hard. And has there been any sort of recent evolution or progress in that space?
Interestingly, conversational interaction is the problem I started working on for my PhD thesis decades ago. I'm still working on it. So it is a hard problem and it is not solved, but we are making huge progress in getting there. The reason it's hard is that if you think of what it takes to have a conversation like the one we are having, or like you might have with a friend over lunch or any other conversation, there are multiple things involved in that. One, of course, we have to understand speech. We have to understand the sound waves coming out of each other's mouths and make sense of them. We have to account for accents and noise in the environment and all of the rest of it. Turns out we're extremely good at doing that as humans. And as of about 5 years ago, computers have pretty much become as good as humans. There are, of course, caveats and different use cases, but we're reaching the point where speech understanding can be done well enough to power conversational AI, maybe not necessarily at human levels. So that's kind of one problem. The second problem is maybe the harder problem, which is once you've figured out what the words are in the sound waves you heard, how do we make sense of the words? What do they mean? Natural language is inherently highly ambiguous and depends on context. So if I asked you, for example, do I need a coat this evening? The answer would depend on if you're at a formal event and we have a dinner planned and I'm asking you, do I need a jacket? Is it going to be formal? Or it might be, hey, is it going to be raining outside when I visit you? Am I going to need a raincoat? So even a simple sentence like, do I need a coat this evening, can have multiple interpretations depending on context. And so have computers figure that out from context. And some of this context may or may not be in the words that were just said. There might be weather is not something we just talked about, but it still factors into the answer to that question, right? And then you have to sort of figure out the appropriate response to that. The response depends on what you and I know already in our shared context. So I'm not going to reply with something that you already know. So all of these things have to work together in real time. Getting all of that to work is really, really hard. Getting computers to understand our context, understand our shared understanding, understand these ambiguous word meanings, and of course process speech in a way that would make all of this work smoothly. Getting that all to work together is a hard problem. We've made great progress on every step of this process, but there's still a lot more work to be done.
So some of the things I think that would come up in context in a conversation that I would look at are where is somebody located, maybe how old they are. You know, I might answer a toddler differently if they asked if they needed a coat in the evening. It would make sense to me in a different way that they were asking. I think a lot of computers, I'll just say computers in a general sense, but different kinds of sensors and compute devices that we carry on or around us, or ubiquitous or ambient computing that may be surrounding us, can actually determine these contextual situations moving into the future. So are we going to use those new pieces of data to inform the interaction, or is it going to come separately?
We will be using those. So if you think about it, there are kind of three broad categories of what I was calling context. One is what was just said in the conversation thus far. I might refer back to something that was said, 2 or 3 turns ago, and build on that. We both have heard that, and there's shared context that we have. So that's one kind of context. Computers are fairly good at capturing that now with some of the largest models that we've seen from some of the tech companies and others. Second kind of context is context of the world around us, shared world knowledge that we both have. We both know that birds fly, except ostriches don't, so forth. And we could use that context without having to explicitly talk about it in the conversation. So that world knowledge, if you will, is another kind of context. And then there's the third type, which is the one you mentioned, which is knowledge of each other, knowledge of who you're speaking to. It could be their age, their goals, their needs. The latter is the hardest in some ways for the computer to detect automatically, particularly given new speakers who are interacting with it. But it's also something that could be brought in from other sources. We may know, for example, if you have a person calling into a call center for support, we may know something about that particular customer based on their account records and so forth after we've authenticated them. So we could get additional knowledge of the hearer, of the other person in the conversation through those means. So we really have to get to a point where we can bring all of this stuff together as easily and naturally as humans do.
And how are we doing that? How are we getting to that point?
We are doing that by bringing in more types of data. So data comes in chunks. For example, we can ingest books and documents or other kinds of photographs, other kinds of data ahead of time and build a model, if you will, that provides context for the conversation. And we also have data coming in real time, streaming data. And for example, as we are talking, we're both now sharing data with each other that context for the conversation. So we have to be doing data ingestion, and we have to be doing it at very large scale to really cover all of the kinds of things that you and I might have in common or know in common. So that's one way. Those data that come in have to have a source. How do we get the data in? Maybe it's documents, but maybe there's sensors out in the world. We might get weather data from weather sensors. We have now sensors in our homes as well with our smart home devices. There's a lot of data about, for example, which room I'm in and which lights are on, etc., because my smart home controller knows all of that and use that. So, for example, if I ask my smart home controller right now to turn off the light, it knows which light I'm referring to because it knows which room I'm in. So those are data that come in from the immediate context through different kinds of sensors. There are sensors in our cars, there are wearable devices that we wear, all of which producing data. With the user's permission, of course, to be cognizant of privacy, we want to be able to use some of that data in order to create context. So those are some of the new ways in which data has been brought in to help conversation. As I mentioned, one of the tricky issues there is sort of figuring out the right balance between being helpful and being relevant and privacy.
I'm thinking of we have no sort of globally orchestrated kind of privacy standards at this point. We have GDPR, we have various regional standards, various vertical standards like HIPAA in the United States. But I'm also sensing that a lot of the critical infrastructure that everybody is using all the time is moving into a ubiquitous computing environment. Even when you go remote, there will be over time satellite communication available to you and present constantly. I am wondering, is there any way to actually sort of hide or have complete privacy moving forward? Or has the world just changed in such a way that we're so interconnected now that you may have privacy in the sense of your data not being abstracted from your identity, but actual collection of the data is kind of a fact of life?
The answer is yes to both. There is a way to be mostly private, which is you can go off the grid. No one necessarily wants to do that in this day and age. Just like you can use cash instead of credit cards and not have anyone track what you're buying. There is kind of a more, I think, modern solution to this question, which is that just because some data is being sensed doesn't mean that data has to be collected centrally in a form that could be misused. So I'll give you an example of this, and I'll talk about the technology that does this. If you use predictive typing on a phone. I know this works on the Google phones and on Android phones with the Android keyboard. As you're typing, we will predict the words and sometimes even phrases or sentences that we think you're going to type. Those predictions are personalized to you. So Camille's predictions are different from Ashwin's predictions. What's interesting about that example is we do that without the data ever leaving your phone. So Google never sees your data. Google servers never see your data. It's done completely privately.
So you have a little AI engine sitting on the phone that's keeping my data local and learning from how I respond?
Right. It's a combination of two things. One is that, so there is an AI engine embedded in your phone that can do local learning to help you without necessarily revealing any private data to anyone else. There is also a technology called federated learning that we talked about. I think Google published this a couple of years ago, which can aggregate the learnings from typing across billions of phones in a completely private way. So without your data ever leaving the phone, if you're starting to type something that you have never typed before, but thousands of other people have, we still want to be able to predict a likely next step. And we can aggregate the learnings from multiple devices without ever looking at your data. The technology is called federated learning. It's also used for federated data analytics and is very, very powerful. So there are newer technologies like this where you do some level of edge computing or edge ML, machine learning, along with federated learning to provide the kind of help that people would value in a completely privacy-safe way. One additional component to add to this is there are also technologies, for example, data loss prevention from Google Cloud, which will filter input streams of data for any kind of personally identifiable information. If you have a document, for example, and you're trying to process that document, let's say you're an insurance company, and you need to process records or invoices or other things, we can automatically find and delete or mask examples of PII, personally identifiable information, so that your name or address, social security number, phone, etc., are never shared. And those things can be done automatically. So in the event that your application does require data to be centralized, identifiable data can still be masked to preserve your privacy. So there are a number of techniques that can be used to, I think, help people with AI in today's world without violating privacy.
I'm going to pester you a little bit on this one thing because you mentioned the phone learning my particular answers. And I've actually wondered about that because I feel like my phone is getting better at predicting how I'm going to respond to something. It's like a personal challenge. I almost never type the thing that it ends up showing me, partly because I get annoyed that it's right. That is what I was going to type, darn it. And then I change it, purposely change it to something else. So I'm kind of wondering, are we customizing for me, Camille, an individual, or are we just pigeonholing? Are we ending up being, this is what you usually say, so over and over again, we're going to feed you the thing that you usually say so that you really never branch out, and now you're kind of becoming a caricaturization of yourself. How do you avoid that problem?
So that's an example of a larger problem that sometimes is called the filter bubble. When you read news, for example, on a news feed online, regardless of which site you use, when you listen to radio, I dare say this may happen with some of the podcast recommendation algorithms that maybe your podcast feeds into, and typing on the phone and other things. As these personalization models get better and better at modeling you, they get also better and better at filtering out things that they think you wouldn't want to see. Mm-hmm. But in doing so, they're also now restricting and in some sense narrowing you into a filter bubble. You're living in a little bubble world of your own with very little peripheral vision into what else is going on. So to avoid that, algorithms need to be designed in ways that do allow a little bit of what in machine learning we call exploration, in addition to exploitation. So in addition to building on what we already know about you, so following low risk, tried and tested route, you also want to be experimenting a little bit and exploring other alternatives. How much you explore versus exploit depends on the use case. If you're typing and your job is just to get this thing typed and move on to other things and it's not important enough, maybe For exploitation is fine. Once in a while, you might type something different. But most of the time is right. Let's just move on to something else. If you're reading news, you sure as hell do want a broader viewpoint because otherwise we just end up with more and more segmented viewpoints of people that never talk to each other. So you maybe do like to read, people have a confirmation bias. They like to read what they already believe.
Mm-hmm.
It's always challenged a little bit. So depending on the application, we can tweak these trade-offs and give you the kind of broader worldview that you would like while still helping you expeditiously on the path that you probably are going to take.
Let's talk a little bit about some of the broader trends that you see happening in artificial intelligence. And I'm just kind of using that as a blanket term. We can pick machine learning or any sub aspect of that you want. What do you think are things that people are arguing about right now that will be settled over time?
There are several different things depending on how much in the weeds you want to get. I think at the high level, there are maybe 3 or 4 topics of discussion that are real critical issues. One, of course, is the data privacy and security issues we've already discussed. Another is that the newest models, particularly natural language processing, but also vision processing or for video for self-driving cars, etc., the newest AI models are very, very large. Sometimes they have billions of parameters. The cost of building and training these models and using these models is very large. It's estimated the latest AI models double in the compute requirements every 3 months or so.
Wow.
You compare that with Moore's law, with computers doubling every 18 months, AI is far outstripping the ability of our computers to keep up. So there are techniques being developed to deal with that, but it does require a lot of compute power. It does require a lot of data. It does require a lot of energy as well to power these things. I'm actually very excited that we can take some of these large models and shrink them down to where they run on a phone without draining a battery. I think that's a good trend, but we have to do a lot more work on that. And there's a lot of discussion around this size of models and what can be done to limit the size. There's some newer things being published, for example, by DeepMind, using much smaller models to achieve comparable results using new techniques. So that's kind of another dimension. The third dimension is, if you remember back to the old days of AI, when we talked about knowledge-based systems and expert systems, and this idea that we would program all of the knowledge that humans have into machines, and then they would be smart. We kind of, in some ways, threw the baby out of the bathwater by saying we don't have to program anything knowledge-wise. We'll just give the machines data and they'll learn everything. It turns out that you do need some knowledge as well as all of that data. And there's some very promising work being done by universities as well as technology research labs on combining some of the knowledge-based approaches with the machine learning approaches we've seen to get the best of both worlds, do a lot more than you can with either approach alone.
Could you give us an example of that? Like what is the difference between knowledge-based learning and machine learning, and how do they come together?
So knowledge-based learning would be, for example, if we are talking about some topic, maybe it's maybe it's politics, maybe it's the weather, maybe it's something technical, or maybe it's just a social conversation over lunch. And what happened with this ball game last night? We have knowledge about that isn't just generated from examples, millions of examples of conversations that people have mined. It happened last night. So that's one kind of example. So current events. Another example might be there's just general background knowledge we have. We know, we know about different kinds of animals.
Birds fly, as you said before.
We know birds fly. That's not something we are learning by reading millions of books about birds flying. We just know that from a few examples because we experienced that or we were told in school or whatever, depending on the knowledge. So we want to be able to capture that knowledge. At Google, we use something called the knowledge graph. We have a very large knowledge graph with billions of facts about really everything that has been learned over the years. Now, these facts are learned through machine learning algorithms, but once learned, they can then be leveraged as knowledge rather than all of the raw data being used every time a new model has to be trained. So we can bring the knowledge from those knowledge graphs along with the conversation analysis that the machine learning algorithms are doing as we are talking to have a more interesting and better conversation with an AI agent than you could if you just use the knowledge or just used.
Will AI be good at innovation, or maybe it already is, in the sense of, I think a lot of times with humans, we put people on certain problems and they end up being a little bit siloed. So, okay, human, you're going to solve the problem of data centers that use a whole bunch of power. How can we reduce the power? And now humans take AI and say, okay, we're going to put AI in the data center and it's going to learn and it'll be able to help us figure out how to optimize, power use, et cetera. Something where you're taking two completely unique problems that different people in like different industries are looking at, but AI might be able to connect. Like, how do we get to that point?
There's been a little bit of work on that. Two very different answers to that question. One is there has been some work. There is work now, for example, not necessarily at the level of applying learnings on energy problems across these kinds of domains, but looking at, for example, scientific literature from two different scientific disciplines and drawing connections between them to provide insights that we as a human race did not have because no one's read both, had expertise in both those disciplines. And there are lots of good examples of this. So that's kind of one kind of answer. The other kind of answer I would give is, I think we are not necessarily trying to mimic or replace every human function using AI. I think the idea of AI is that we would use it to automate some of the more mundane things that are maybe difficult and tedious for us. But having automated that, for example, controlling a power plant, we now free up the humans to do higher level and more important things with their lives. And so I don't know that AI would ever automatically recognize, maybe it would, who knows, right? But that energy saved here could be used to power a town there. But if a human provided that insight, I'll bet you we could get an AI to figure out a good and optimal way to do that. So I think that's the kind of human-machine system that we want to go after. The particular area of AI I work on is called interactive AI. It's about AI in a human world, helping and augmenting human ability instead of literally just replacing humans.
Right. And it sounds like the way that you're describing that, the problem statements are still defined by humans, and then AI helps to solve that or look for trends or patterns that can help solve it. Is that true, or is AI also bringing forward like suggested or potential problem statements that it could then help solve?
I think that's largely true right now. AIs are good at solving problems, at sort of figuring out the right algorithms or the right model to solve problems, but not necessarily at posing the problems or identifying them in the first place. There are, again, particular examples where AIs are good at finding problems. One example that comes to mind is from the financial industry, looking for anomalies in financial transactions to identify that there might be a problem there, and then bringing that to human attention, who can either then intervene to solve the problem or design an AI to go solve the problem. So there are, I think, specific examples like that. There's also, I think, AI systems that are pretty good at detecting certain kinds of diseases and syndromes in humans, sometimes earlier than humans can, sometimes better than humans can, sometimes in concert with humans, doing better than either one alone. So I think that kind of problem detection can be done in particular kinds of use cases. But this kind of big idea that you threw out of societal level problem generation, I think is still ways in the future. I won't say we would never get there. We've been very good in the AI community at solving things that we thought could not ever be solved by non-humans. I think this particular one is still a ways in the future.
Well, really fascinating conversation. Thank you, Ashwin Ram from Google, for joining today. I have one final question for you. What is your favorite Google Doodle? Do you have one? And have any been designed by AI?
Oh, good question. I don't know the answer to that. I can find out, insert it in later. My favorite Google Doodle. I'll tell you one that was not necessarily a doodle. You could take a Google map of an area and play Pac-Man on the streets of your neighborhood or the city you like or whatever.
Thank you so much for your time. I really appreciate it.
Never miss an episode of What That Means with Camille by following us here on YouTube. You can also find episodes wherever you get your podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.